This is the history of spaceflight and space technology. I'm Andy Chaikin. This is week 12, the final week of the course, and the topic is Mars. Mars has always been tremendously fascinating to human beings. It's been a magnet for human curiosity, and it really became especially intriguing in the latter part of the 19th century, especially because of the writings and statements of a Boston Brahmin astronomer named Percival Lowell, who became infatuated, I don't think that's too strong a word, with Mars, and even built his own observatory in Flagstaff, Arizona. It still bears his name, to look at Mars during one of its close approaches to Earth in the late 1800s. Lowell, when he looked at Mars, was positive that he saw networks of fine lines that were appeared to be straight and interconnected and geometrically precise. And to Lowell, these represented the canals of a Martian civilization that was trying desperately to survive on a world that was becoming one big desert. Now, Lowell had gotten the idea of the word canals, actually in Italian canali, from an Italian astronomer, Giovanni Schiaparelli, who also claimed to have seen lines on Mars, but he did not attribute them to anything artificial. And his word canali in Italian just meant channels. But Lowell took it to another level and literally interpreted them as signs of a Martian civilization. Well, the scientific community didn't want to have much to do with Lowell, but he profoundly influenced the public's imagination and helped give rise to a whole raft of science fiction stories about Mars, including Edgar Rice Burroughs' tales of John Carter, a Virginia gentleman who manages to transport himself to Mars simply by thought and ends up in a whole another life on Mars as in his interactions with the Martians there. Orson Welles very famously staged a radio play on Halloween of 1938 called War of the Worlds, based on the H.G. Wells story about a Martian invasion of Earth. And then, of course, in the 50s, a Martian invasion was always a good plot for a scary movie like Invaders from Mars. Well, the real Mars was starting to emerge in the 1930s, 1950s. The Mars map that you see there by a French observer named Antoniadi looks nothing like Lowell's Mars. It does show a network of disconnected and irregular, or I shouldn't even say a network, an array of discontinuous and irregular markings, dark markings on brighter colored background. By 1954, you see the great space artist Chesley Bonestell painting a Marsscape as it was then imagined by scientists. And it's very much like the deserts of Earth, except that the atmosphere is thinner. You can even see some dust devils in the background. And notice that in the right side of the picture in the background is a greenish area that is, at the time, the best guess for what the Martians, if they existed, might be like. Nothing more than simple plant life. Now on the right you see the finest, one of the finest photographs of Mars ever taken before the space age. It was acquired by a Caltech astronomer named Robert Layton, who created a mechanical system to offset the blurring of the atmosphere for the 100-inch telescope at, or rather the 60-inch telescope, I should say, at Mount Wilson near Los Angeles. And he did manage to produce telescopic photos of Mars that were much better than what had already been obtained, but still, because of the blurring effect of the atmosphere, there is maddeningly little detail. You basically just see these dark markings that are rather ill-defined on a kind of an ochre-colored desert. At the top of the image, which is the south portion of the planet, you see an ice cap, and astronomers had seen those ice caps grow and shrink with the Martian seasons, and they'd also seen the dark markings change, and that fueled a lot of the speculation about whether there might be plant life on Mars. But the only way to find out was to go to Mars directly and explore it, and that became possible in the early years of the space age. The first space probe that made it to Mars successfully was Mariner 4, which lifted off from Cape Canaveral in November of *64, carried a number of different scientific instruments to take close-up pictures, to look for a magnetic field, to analyze radiation of the space environment, and so forth. And you can see on the right Mariner 4 being launched atop an Atlas Agena rocket. Mariner 4, because it was going to Mars, it was much further away than any previous space probe. Up to now we'd had space probes that went to the moon, and we'd even had one fly past Venus. Well, Mariner 4 was going to fly past Mars, which never comes any closer than 35 million miles, and at the time of the spacecraft's encounter, it was going to be quite a bit further than that, maybe 100 million miles. So, we're talking about enormous distances to send any kind of data via radio signals. And so for that reason, Mariner carried, for example, an imaging system that was the first digital imaging system ever sent into space. It would send its data as a series of binary numbers. And even then, the transmitter on the spacecraft put out about 10 watts, but that diminished to 10 to the minus 19 watts by the time it reached the giant dish antennas of NASA's Deep Space Network. And it took 8.5 hours for every image of Mars from Mariner 4 to reach the Earth. And it took some very fancy mathematics to get Mariner's signal out of the noise of the transmission. So, it's quite an achievement simply receiving those images. Well, in July 1965, the first pictures started to come in, and this is the first close-up picture. It doesn't show much, just a horizon and what seems to be a haze layer above the surface. But they decided that was in fact not haze, but a flaw in the image caused by light leaking into the camera. The sun is very high over Mars in this picture, so you don't see a lot of detail. Later images, as they came in, did show detail, and it was absolutely stunning and surprising. And the fact was that Mars was, in these pictures, covered with gigantic impact craters, much like the moon. Well, this was not what anybody had expected. They thought they might see some craters, but certainly not lots of them, and certainly not big craters like the one in the lower right there, which is about 60 miles across. Now, for craters that big to still exist on Mars meant that the surface had to be extremely ancient, dating back to the early epochs of the solar system. So suddenly, we were presented not with a Mars that might have life on it, but an ancient fossil left over from some very, very early epoch of the solar system. To make matters even worse for the prospect of life on Mars, Mariner's radio signals pass through the atmosphere of Mars by design, and by watching the radio signals disappear, they were able to analyze the structure of the atmosphere and find out that the air pressure on Mars is only 0.7 of 1%. That is 7/1000ths of what it is here on Earth. Furthermore, other instruments suggested or confirmed that Mars lacks an ozone layer, so that there was nothing to screen out deadly radiation from the sun. And with that low atmospheric pressure, water could not exist as a liquid on the surface of Mars. So what you had was a frigid, radiation-bathed desert. And the New York Times, in an editorial, referred to Mariner 4's Mars not as the red planet, but the dead planet.